Okay, so we are looking at using Aspen Plus, how to use Aspen Plus, what Aspen Plus is, and then why it's important for us, especially as people who are doing chemical engineering, petrochemical engineering, petroleum engineering, any of these disciplines. So from our discussions, you've mentioned that you've had some exposure to Aspen HYSYS. So as I said, it will help us really move a bit faster because we understand how to position blocks and connect them and all these things. So we'll just have a little introduction to the software itself, and then we'll be done for today. So Aspen stands for Advanced System for Process Engineering. It's a software that we can use to model and simulate different processes, especially chemical engineering related processes. And these are some of the things that Aspen can be used for. So you can use it to estimate properties. If you want to determine the property of maybe a certain mixture, you have maybe a mixture of or a binary mixture, you have two compounds mixed together. You want to determine their properties. You want to be able to get diagrams like your TXY diagrams, your equilibrium data, or maybe you just want to simulate what happens around a single unit. So maybe a pump, a reactor, a compressor, a turbine. You just want to see what happens around a single unit. So you can analyze that or over multiple units. Then the interesting thing about Aspen is that it's not limited to just these things. So there are other packages involved in Aspen that can help you do energy analysis. So you can okay, well, we'll get into those terms later on, but then you can do some energy analysis. You can also do economic analysis as well. You can do sensitivity, looking at what happens when you vary something on the input side, or how maybe if you make a variation, what effect does it have on your output, right? Then we can optimize, you can do dynamics. So things like what you are doing in process control, to an extent you can do some of these things in Aspen, having your PID controllers and all these things. So Aspen is actually very, very diverse. It has a lot of things that it can be applied to. And the truth about this is it's a tool. And just like every yes, please, is there a question? Okay. So Aspen is a tool, and just like every tool, the way to become good at using it is by practice. So you would try out different examples, you make mistakes, you come back, you correct them, and over time you would learn. So you can get specialized in one aspect of Aspen. Maybe you are very good with energy analysis, you are good with that. But it's important to be able to understand it holistically, knowing every or a bit of everything so that you can work on different things as well. So I'm actually glad that you guys have some background with HYSYS and you are adding on Plus as well. Okay, so we'll look at the software itself, the interface itself. If you want to start Aspen, just like you start every other um, computer application, you just double click on it and then it opens up. When it opens up, this is the first interface you are going to see. So I'll switch to the software now. Please, if you don't see my screen or you are not hearing me or something, kindly bring my attention to it. So when you first open up Aspen Plus, just a minute, you may see this template. So it depends on the version you are using. I am assuming that most of us are using, or let me not assume, but most of us might be using version 11 or version 14. So usually you'd see a template like this one, interface like this when you start. Then you can click on new simulation. So let me close this one. So it's taking some time to load. Okay. While it's loading, let me come back to the slides. So you can click on new simulation. So this particular one we see here is with the version 11. So the new would be at the side here. With the one I showed you, that was version 14. You just need to locate where new simulation is on your screen. When you do that, it would bring you to a point where you now have to choose blank simulation. So over here, you see that there are a number of things in the left pane. You see my templates, install templates, air separation, chemical processes, electrolytes, and it continues. Over there, we have some models that are already inbuilt. So maybe you want to work with a gas processing kind of simulation, you can click on gas processing. It would already specify some of the properties you will need, the property methods you will need, and all these things. But then for the most part of it, what we always do is that we build from scratch. So you click on blank simulation and then you click on create because you want to feed in your data. You don't want pre-existing information. Please, I hope you get me. Okay. So after you click on your new simulation, it brings you here. So for this one, it means I'm now coming to put in all my details myself. There are no pre-specified details already there for me. So I'll come and put in everything here. Now with this particular interface, we have our workspace here, and then we have a menu bar. We have our left pane or our navigation pane to the left side. And then down here, we have a status indicator or a status indicator. So it will let you know if there are errors, if there are warnings, if there are things that you should pay attention to. This is generally how it looks like. One of the first things that we do with Aspen Plus is to learn how to choose our components, the different compounds or chemicals that we want to work with. So I'll spend a little bit of time here. On this particular interface, if you want to find a particular compound or a chemical or an element, you click on the find button at the bottom over here. So when you do that, you would have this popping up. Now over here, we have three different things that we can do. You can click on begins with. So it means that whatever you enter, Aspen is going to look for all the compounds that begin with that particular thing. So if you should type something like methyl and you should search for it, it will look for everything that begins with it, right? Or you can look for things that contain it, whether it's at the beginning, the middle, or the end. And if you should use equals, it means you're looking for the specific thing. So it will look for that particular compound for you. And we are not limited to just typing the names in this form. Sometimes you can type out the chemical formula and Aspen will still be able to find it. If you want to be very, very specific, maybe you know the molecular weight, you know the boiling points, you can enter those details to limit the range of what Aspen would have to look for. But then this is one of the ways that we can go about searching for compounds. So it's taking some time to still search for it. My system is a bit slow, but it would come. And while we are waiting for that, if you look at the top here, you see compounds, you see data banks, you see PubChem. Now, under data banks, the data banks, what they do is that they store different information about different compounds. So there are some data banks that have a lot of information about maybe compounds that relate to polymers. Okay, so we are getting some details now. So you notice that we look for words that begin with methyl, but we are seeing one trichloro something, right? I think it's trichloroethane. Yes. But then if you look at the alternate name, it begins with methyl. So it's not only looking for what it begins with in the compound, but then in the alternate name as well. So these are some of the things that you can look into. You can even type the alias, you can type the alternate name, and Aspen will find compounds relating to that. Now, what I was saying about the data banks is that if we should come to the data banks, you would see all these names. They may look a bit funny, but then the thing about them is they store different information about different compounds. So here, for example, we see APV 140 solids. If you want to work with solids, it's a good data bank to work with. You would see other ones like this one over here, the INITIATO, right? It's actually standing for initiators. That's very good if you are working with polymers, because with polymers, you may need an initiator compound. So if you want to do that, having this data bank selected helps you. If you want to work with biodiesel related stuff, if you want to work with, there's even one for polymers itself. So there are different data banks that would help you find the different compounds you are looking for. I'm stressing on this because you may search for a compound and may struggle to find it for a number of reasons, and this is one of them. It could be that what you are looking for is not in the data banks you have selected. So normally what I like to do is that whenever I'm looking for compounds, just to be on a safer side, I select all the available data banks so that I don't need to worry about where my compounds may fall. So if you want to select everything, you can just click on this button over here and then it would move all of them to the other side. So now it has selected everything. So if I need to look for my compound, I can go ahead and do so. And the other thing about why sometimes you may not find what you're looking for is how you type it out. So if you're typing out your compounds, you need to be very particular about the names and whether you're leaving spaces or not. So I would show us, let me see if I can get, I should have used equals. Let me cancel it, I'm coming. Let me see if I'll find this. But please, I hope you are following.
Yes, please. Yes, please. Yeah.
Okay, that's good. Sorry, my system is a bit slow, so we may need to give it some time so that it loads everything. But what I'm just trying to show us is that you may type polyethylene terephthalate and may not find it because Aspen will put the ethylene into a bracket. So usually if you're doing things like that, you need to know how the name is supposed to be like, right? And if you're not sure about the name, the compound name, you can type the alternate name. So sometimes typing something like PET may work. Aspen will be able to identify that you're looking for polyethylene terephthalate. So you can just type something like PET, one of the common names for it, and then Aspen will be able to find it. So that's what I'm trying to show us over here. So we can wait for that to load so that we see if it comes up. But then the other way you can also search for your compound is if the compound is a very common one, something like water, oxygen, nitrogen, you can just type it directly here where we have component ID. So I think this is taking too much time. So you can just type it here. So maybe I type water, and then if I should click on enter, Aspen would identify it and it would fill out everything else for me because Aspen is able to determine what water is. Or I might type O2. So you can type O2 or you can even type oxygen, and Aspen will know what exactly you are looking for. Okay, so wait for this one to also come. For this one, I need it to come before we continue. Then let me add just methanol to it. So we'll just work with these three for the meantime. Okay, now we've selected the compounds we want to work with. You'd notice that under type, you see the word conventional. Sorry. When Aspen uses the word conventional, it means that it's a common compound that usually can exist as a vapor or a liquid. So there can be some kind of vapor liquid equilibrium between it. So most of the very common compounds that do these things. So it can be vapor, it can be liquid, or it can be a vapor liquid mixture. Usually that's what we have for conventional um, systems. But then maybe you want to work with something slightly different. So if you should come to where the conventional is, you see a drop down arrow and we see different things here. So maybe what you're actually working with might be a solid. You can click on solid so the Aspen knows that you're dealing with a solid. Or it might be a biocomponent. It can be something non-conventional. So non-conventional is some anything else, right? That you may have to now come and specify extra information about. Then you can have pseudo components, assays, and blends. So these ones are more related to petroleum related stuff. Hypothetical liquids are more for metallurgical operations. Then we have polymer, oligomer, and segments. Those ones are if you are working with polymers. So you need to know exactly what you are dealing with and then the kind of compound that you would use. But then for introductory Aspen, most of the things that we use are going to be conventional. So we'll just keep it as it is. Now, one advantage of Aspen in chemical engineering is that you can use it to determine the properties, as we said earlier, of different compounds and different species. So the way we can do that is that if you should come over here, we see data source. Please, can we all see it? Where we have data source. Please, can we see it?
No.
Okay, but can you see my screen?
Yeah.
Okay, so just follow me. So under file, you see clipboard, right?
Okay.
Then units, then navigate, then tools before data source. So can you see data source now? Hello?
Unit then.
Units, navigate, tools, then data source at the top. Can we see it now? Over here.
Oh, okay, okay.
Yes. So we have three different options there. I think one of them would require that you are connected to the internet and it will take you online to get to your source of data. But then if, for example, let's say I click on the first one, NIST, this is the one that I normally use, right? So here we can choose any of the compounds we have chosen. So maybe water, right? And then I can click on evaluate now. If it's a binary mixture, you can specify that and then select the second compound in addition. So maybe water and methanol. You can do that as well, right? Okay, is there a question? Yes, please. The class is being recorded. So we will just work with a pure compound
Thank
for
you.
now. Sure. Work with a pure compound for now. So let's say we want to determine the properties of water, right? I can click on evaluate now, and then Aspen will run and then give me some properties. Okay. So I just got a reminder that the meeting will end in about 9 minutes. So after about 5 minutes, we can take a break. I'll send us another link. Then we rejoin and then we'll continue from there. Okay, so now these are the properties of water that Aspen has been able to determine for us. We have the pizza eccentric factor, compressibility factor, critical volume and pressure, and temperature. So we have all these details that we may need, solubility parameters, freeze point temperatures. So if there's any information that you need, you can work with these data sources. This is one of the advantages of Aspen. It's able to determine all these different properties, and you can even see some of them at the side here. So maybe I want the normal melting temperature. I can click on that, and then Aspen should direct me to the particular value. So these are some of the very, very interesting things about working with Aspen. Now, the second thing we would do is that let's look at how we can take it even further to get more thermodynamic and even fluid transport related properties of the compounds that we have, right? So thermodynamic properties like the ideal gas heat capacity, the enthalpy at a certain point, the entropy at a certain condition, or maybe fluid properties like maybe the viscosity, any of these things, Aspen can help us find them. But before we do that, we need to specify or we need to determine what we call the property method. So right now we've specified the components. That's the first part. The next thing is to specify the property method. So you can click on the next button at the top here, or you can come to the navigation pane, the properties pane, and then you would see methods. Now you notice something about the methods, what we see on the methods. You see that there's this red and white mark on it, right? The red and white mark means that something has not been completed or there's something missing that you need to fill in. So usually if you should have that, Aspen will not allow you to run the simulation. So you need to fill up whatever is missing before you continue. So we can click on methods and then we can specify the property method. Now the property method is just a collection of different models that pertain to the compounds that you may have in your system or the kind of system you may have. So it's very important to know the kind of property method that you need. If you're working with ideal gases, there's a property method called ideal that works for it. You have methods that are related to the equations of states that you know from thermodynamics. So Penn-Robinson, Van der Waal, SRK. So maybe you want to work with something that models your system using the Penn-Robinson equation of states, right? So you can use the Penn-Robinson property method. So under the method name, we can choose the method that we are looking for. So if you should go down, you see a lot of these ones. So there's ideal here for ideal gases. NRTL is very, very good for liquid systems, right? It's very, very good for liquid systems. Then there's Penn Robinson. Something like PC Saft is very, very good for polymer systems. So you need to know the kind of system you have and then the kind of method that works best for it. But then there's a rule of thumb that if you don't know the method to use, start with Penn Robinson, right? So if you don't know, you just start with Penn Robinson. And if maybe you are picking or you are doing a model according to something in literature, look for the method that the literature is using and then use the same method. Don't use something else. If you are still not able to determine the best method at the end of the day, in the slides I'll send you, there are notes on choosing the right property method. So it would help you choose it based on things like your temperature condition, if maybe you have an electrolyte in your system, any of these things. So it has different, let me try and get to that page for us so that we see it ourselves. It has different conditions that you can follow to determine that this method is actually the best for me. Okay, I think we'll be there very soon. Okay, so we have the different methods there. So these are just the differences between the equation of states method and then the activity model methods. So we can read more on that. Usually there's a rule of thumb we can follow. So this is it. So if probably your system is polar, then you come down here. Is it an electrolyte? No. Is your system at pressures more than 10 bar? Yes. Then you can come down here. So you just follow it, and then it will lead you to a recommended method that you can work with. But then if you are still not too sure, what you can do is that you can click on methods assistance. Then Aspen would send you to another interface, and then you can now follow the details there, and it will suggest a method for you to use. So this is the last thing we'll do before the class ends. Then we'll rejoin, and then I'll show us how we can estimate some of the thermodynamic and then fluid transport properties. Okay, it's taking quite some time, but it would bring different pieces of information, asking you whether your system is a chemical process, it's maybe something dealing with electrolytes or maybe refrigerants or something, right? So you choose the particular kind of process you're working with. So the first thing you choose whether you want to specify the type of component or the type of process. So let's say I choose component type. Maybe I know I have much information on the different components in my system, but I'm not so much about the process itself. I can choose component type. If I know for the process, I'll choose the process type. So is it a chemical system, a hydrocarbon system? Is it a special system where I have maybe amines or an electrolyte or I have a refrigerant, right? So let's say it's just a normal chemical system. I can click on that. Then it would ask a few more things. Is the pressure more than 10 bar? Do I have pressures that are greater than 10 bar in my system? Is it a high pressure system? So maybe yes, it is. I can click on that. Then it will give me some suggestions over here, right? And it gives extra information. So you can click on these ones and it gives you more information on the different property methods out there. So it's very important because using the wrong property method will give you very, very wrong values. So for example, with the liquid thing I was saying, there was a time that I was working on something having to do with liquids, and I used a property method that was best for gases. The answers I got were far from what I was looking for because the property method was not the best to use. So if you are dealing with very non-ideal liquid systems, working with something like NRTL is better than working with something like um Penn Robinson, right? For the sake of accuracy. So these things really matter. Choosing the right property method. So I think we can break here and then we'll rejoin the meeting. I don't know if we can use the same link. So let's try. If we can't, I'll resend I'll send another link to us so that we can join with that one. So let's drop off now because we have just about 2 minutes for it to end, and then we can rejoin by 8 p.m. and then we'll continue with the rest of the discussion. Okay, so we can continue. So we've looked at specifying the components and then specifying the property method or choosing the property method that we are going to be working with. So now the next thing is that by now we should be ready, we should be set to um, determine the thermodynamic or the fluid or the transport. Sorry, let me use transport. So the thermodynamic or the transport properties, or we should be able to start a simulation. But then we see that it's still not yet active. We still see the red mark by the methods. Usually, if everything is fine, we should see the blue check mark. So what we do is that we click on next. Aspen will tell us what we are left to do. When you click on next, it brings you over here. So this is just something that Aspen is doing to kind of get some kind of verification, right? So it's looking at some binary parameters. When you have different compounds together, there are some interactions that happen between them. So Aspen is just looking at that. These are usually experimental pieces of information. If you have them, you can fill them in. But usually, what Aspen has to be good enough. You don't need to do anything here. You don't need to touch anything here in most cases. So now that we are done with this, you can click on run. Now we see that the run button is active. You can click on run. And then if we look down here, under where we see energy analysis, so if you come to the left, you see the property pane, you see property simulation, safety, energy analysis, and below that you see results available, right? So the results available, there are no errors, there's no issue, everything is fine. So you know that we can carry on with what we want to do. Now let's come back to the top over here. So earlier we looked at data source. We'll go to the far end now where we see analysis. And then we'll just look at pure and binary for today. But you can play around with the others. You can generate ternary diagrams, solubility curves, and PT envelopes. You can do all these things that you would have probably come across in the chemical engineering course by now, right? So we'll just work with pure and binary for today. So we'll click on pure under the analysis tab. I think for some of you, you may not see it this way. You may see the word analysis itself. When you click on it, then these other options will show, if I remember correctly. So you may not see pure binary measure there directly. You may have to click on analysis first before this happens. I think there was one version that did that one time. So in case you encounter such a problem, just look for analysis itself. And then under analysis, you should find what you are looking for. So when you click on pure, you see this interface. Now we see property type. You can select the type of property you want to work with. Is it a thermodynamic property? Is it a transport property? Or do I want to consider everything? Or is it an equation of state alpha function test if you have information on that? So let's look at the thermodynamic properties. Let's say I want to work with the heat capacity at a constant pressure, the CP, right? I can click on that. And one thing to keep in mind, you see that we have so many different things over here, and they are represented with or there are different annotations for them. So we see rho, we see S. We know that S is entropy in thermodynamics. We know that U is internal energy. But what is SONVEL? We may not know. So if you don't know what something is, you can place your cursor over it and Aspen will tell you. So we see that it says the sonic velocity of pure components. Right. So this is just to help us out. There are some things that you may know. There are some things you may not know. You can just place your cursor over it and Aspen will give you further information about it. So let's work with very, very common things, enthalpy. So if you're looking for enthalpy, that should be H. So we can come to enthalpy for a pure component, or maybe it's enthalpy flow for a component, or enthalpy of an ideal gas, right? So let's just click on H. That's the enthalpy for a pure component. Then we can choose the units we want to work in. So do we want to work in joule per mole, BTU per pound mole, calorie per mole? We have all those options here. So we can choose our units. So let's just choose kilowatts. And then we have the different phases. So what I'm working with, am I considering that it would be in the vapor phase, it will be in the liquid phase, it will be in the solid phase, or even a combination? So I can click on both vapor and liquid so that it would do the calculation considering both phases. So to give me the enthalpy for both vapor and liquid phases. Now, the next thing we need to do is that we need to choose the components that we are working with. So let's just choose water from this side. So the way you choose it is you can double click on it, or you can click on it once and click this arrow at the top. If you click the second arrow, it moves everything to the other side, right? So you can just double click the one you want. Then let's come down to temperature. So under temperature, you can choose the units you want to work in. So maybe I want to work in Kelvin. And then you can now enter the range of temperature values that you want to use. So let's say I want to start from 0 degrees Celsius, and sorry, we are in Kelvin. Let's work with Celsius. Let's say I want to start from 0 degrees Celsius to 100 degrees Celsius. So my start point and my end point. If I use equidistant, it's going to use equal intervals between them, right? Or an increment of a certain value. So if I say number of intervals and I choose 50, it will generate 50 intervals for me and the step size will be equal. Or I can determine the increment. So maybe I want it to increase by a value of 2. So from 0 to go to 2 degrees, then 4 degrees, then 6 degrees until it reaches 100, right? So we can do that. We can choose the one we want. Or you want it on a certain logarithmic scale, or you want to enter specific values. You don't want a full range. You just want specific values. So maybe you just want 30 degrees Celsius, 50 degrees Celsius, and 100 degrees Celsius. You can do that as well. So you click on list of values and choose the specific values you want to use. So keep it on equidistant. Then under the pressure, you can enter the pressure you are running your analysis under. So you can also change the units, right? So if we should click on run analysis, we now get our graphs. So we can see the Aspen will give us a legend. So the one in blue is for vapor, the one in green is for liquid. So if maybe we are at 20 degrees Celsius, that's down here, right? For the liquid, we can read the enthalpy of water, or if it's vapor, we can read the enthalpy of the vapor of the water vapor at that temperature, right? And for Aspen, Aspen's reference, because remember things like enthalpy deal with reference. So Aspen's reference is air at, if I remember, I think I'll have to confirm and send it to you, but I think it was air at 25 degrees Celsius at 1 bar or so. It uses air, and then it's has a way it relates to everything else. So you may run a simulation and you're getting negative enthalpies. It's very, very common, right? It's very, very, very common. But I'll get the reference for us and I'll send it to the page. Now, the other thing we can do is that aside just looking at the plots, so let's close this one. Under the same tab, after we've run the analysis, you would see diagnostics, you see results, you see comments, you see status. You can click on results and you will have the information in a tabular form as well. So you have each temperature, then the pressure that it was run at, and then the values as well. So maybe you don't want the graphical form, you want the tabular form. So maybe you can extract some information. You can come to results and then get what you are looking for. So let's try a transport property. So let's say we want to use what should we try? Okay, let's try the thermal conductivity, right? We can do the same thing. So we can click on run or run analysis, either of them. If you click on run, usually you won't get the graph directly. If you click on run analysis, usually the graph will come up. So we can see the results here, the thermal conductivity of water under the different temperatures, right? So we have all these pieces of information available to us. What if we wanted to run a binary analysis? So just as we clicked on pure, we can click on binary. Now this time we need to specify two components. So let's make the second component methanol. We want to look at water and methanol, right? The interaction between water and methanol. Then we can choose whether we want it to be a TXY diagram, a PXY diagram. I hope we are all familiar with this by now because I heard most of us are in final year and then a few are in third year. So we should know these things, right? Hello, please, are we there?
Yeah,
Okay.
but can you mention what the first one means, at least so that we can all binary? Yeah, please can you review us at least the
Okay.
first one so that we can
So
recall?
you know that if you have um, a binary system, you have two compounds mixed together. So maybe you have two liquids together, right? You can analyze what
Yes.
happens as you increase the pressure at a constant temperature, or as you increase the temperature at a constant pressure. Then you get your bubble point curve and then your dew point curve. Or if it's an
Yeah.
isotrope, you have the points where they meet. I don't know if you remember all those things. So it's for vapor liquid equilibrium analysis. Do
Yeah,
you
yeah,
remember
yeah.
those things?
Critical point.
Yeah, so all those things come in. Yes. So maybe once a TXY diagram, we are looking at the temperature varying when we have one particular pressure, or you can even work with multiple pressures in Aspen, right? So we are doing it on the basis of mole fraction. So we can work with either mole fraction or mass fraction, either of them. And then what we are going to vary is water. So if you remember the way these diagrams work, you will vary the mole fraction of one component and the other is implied. So if the mole fraction of water is zero point 0.6, then we know that methanol is zero point 0.4, right? So some of these things, and it's going to start from zero and now one for the mole fraction, so from 0 to 1. For the pseudo and binary, we don't really need to worry about that for the introductory part. But then, if maybe you have a certain system and you need to add an entrainer, I think usually to improve things like the azeotropic points and those kind of things, you can factor it in. But then that's not really going to be today's focus. And then you can specify the pressure you want to run it under. So if you want to run it under multiple pressures, that's fine. But then the disadvantage is that your graph will look clumsy. It will look like there are so many things on the graph. So usually, I think personally, I think it's better to work with one pressure. And if you want to analyze another pressure, you do that one separately, unless you necessarily need to do everything together. Because if maybe you have two bar as well, you have so many. The graph will look so clamped together. You have two different graphs together, so it might be a little bit messy. So we've specified the things we need to specify. We can click on run analysis again. And then let's see the graph that comes up. So we have a graph. Does this graph look familiar? Do we remember seeing things like this?
Yeah.
Okay.
Yeah.
That's fine. So we know bubble
Wow.
point, dew point, vapor liquid mixture region. We can do all these things in Aspen, right? So you can vary it under different conditions of pressure, look at different temperatures, what happens over there. And then just like we did, you can just like we clicked on results earlier, you can click on results here as well and get all these things that all these pieces of information you need. So the gamma values, the K values, right? The K values. We have all these things in there. And you can also, I think if okay, this is if you have additional properties that you want to work with. So we can try some of these things out. So I think for today we can end here. Is there anything else I may want to add? I think for the introductory part, this should be fine. This should be fine. Yes, this should be fine for the introductory part. So, next week we'll move to the simulation window itself, and then we'll try out a few things as well. So you can practice working with components, property methods, estimating different properties, seeing the different graphs, um, changing values here and there, seeing what happens. Right? You can do all of those things, and then you'll be good to go. But then there are so many things that we can still do under this particular um interface under the property section. So you can decide to specify specific properties that Aspen may not have for certain compounds and all those things, right? So if you have extra information, you can put all those things in there. So yes, we'll end here. We'll end here for
Yeah,
today.
hello.
Yes,
Sorry. Yeah, please, concerning the fluid package, you say if you select the wrong fluid package, it will
yes.
give you wrong values than expected.
They may look
So
as accurate
how
as
are you?
necessary. Yes.
Yeah, so how are you able to know the kind of values to expect before every simulation
Okay. Okay. Um,
or research?
Research is one of the ways, and sometimes if it comes to numerical values, that might be a challenge, right? So usually, if anybody should even do an Aspen related work, you are required to state your property method so that people can confirm. So if maybe you see literature and they say that they had an Aspen simulation, they would have to state their property method so that you know that this is what they use. And usually they'll give reasons for it. So the property method, it has to be selected based on the reasons you spoke about earlier. That's the kind of system you are working with, the kind of compounds you are working with, right? If it's gases, you know what is best for gases. If it's a polymer,
Okay.
what is best for polymer. And the information is out there. So you can say that, or you can look for it that, okay, maybe I'm working with a system, I'm trying to simulate a polymer process, right? What property methods are best? You will get the information. And because Aspen builds all these things, they also have their store of information. So they have templates you can follow if you want to build if you want to build a polymer simulation. Work with this method, work with this method, work with this method for this kind of polymer. Work with that and that and
Okay.
that for that kind of polymer. So the information is out there. You are not left to
Okay.
yes, please. So even in the slides I'll send you, there's information on choosing what to consider in choosing the right property method. Is that okay?
Okay. Thank you.
Yes, you're welcome. Are there any other questions? Okay. So if there are no other questions, then we'll end here for now. So we'll continue next week. Yes. Thank you for your time.